This week, we speak with Grant Ongers from Secure Delivery. In the news segment, we zoom out from security flaws to look at the bigger picture of communicating security issues. Then we watch so many secrets spill from services and apps. Microsoft sets out the attack for Kubernetes while Win32k strikes back from the past. And more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more. Nearly every business today relies on mobile applications, yet the vast majority do not adequately secure them. Once downloaded, mobile apps escape your control outside the secure network perimeter, thus making them easy targets for hackers. Enter GuardSquare. From the makers of ProGuard, GuardSquare integrates transparently and seamlessly into the development process, adding multiple layers of protection to Android and iOS applications, and effectively hardening apps against both on-device and off-device attacks. Request a demo today of GuardSquare at securityweekly.com/GuardSquare. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome to Application Security Weekly. This is episode 102, recorded April 6, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
I'm being attacked by the sun today.
Oh, we're going to watch it creep across as we go through the episode. We've also got John Kinsella. Hey, John.
Hey, guys. How you doing?
Pretty good. Not being attacked by the sun, it seems. So that's good news on your side. It looks.
He's in Seattle, of course. I don't think they see the sun up there, do they?
Hey, it's actually sunny this week. So.
That's right. Yeah, rare sun in Seattle. We have officially migrated our mailing list back to our original platform. We apologize for any double mailings or lack of mailings you may have received in the interim. We have our categories nailed down, and you are now able to customize what you receive from us based on your preferences by visiting securityweekly.com/subscribe and clicking the button to join the list. Once you have joined, you will also be able to go back and update your interests so that we can grow with you as you progress through your journey in InfoSec. Is your open source code secure? Learn how to verify your code during development, not after the build, in our next webcast with Synopsys. Register for our upcoming webcasts or virtual trainings by visiting securityweekly.com/webcasts. You can also access our on-demand library of previously recorded webcasts and trainings by visiting securityweekly.com/on-demand. Each webcast will earn you 1 CPE credit that we will submit on your behalf if you provide your IC² number. Grant Ongers is co-founder and one half of the bearded duo of Secure Delivery. He has 20-plus years in ops, doing everything from running operational teams in global NOCs to managing mainframe and database systems, teaching classes and consulting on ITIL, and running Prince 2 and King 3 projects to both the public and private sectors throughout the world. Hello, Grant, and thank you for joining us.
Hey there. How you guys doing?
We are doing quite well, and we're glad you've come on because you have one of the more provocative segment titles we have about probably doing AppSec wrong. And I'm going to guess already that it's easy to throw a label like DevOps onto an AppSec program, but just because you have the label, that doesn't mean it works like it says on the tin. So what does it mean to do AppSec wrong, and hopefully, how can we do better?
I guess the two things that primarily come to mind is that we're trying to do something that's called DevSecOps, which is injecting security somewhere between development and operations, which obviously is not where it should be. That's not where we should be doing security at all. And the second thing is we as security people are trying to do all the work. I've gone on record and been quite vocal about people, how we don't have a team that deals primarily with performance of an application. But I would argue that performance is a more fundamental, more important non-functional requirement to anything that we put out into the world than security is for a lot of things. So why do we have a separate team doing the security of it? And why are we as security guys trying our hardest to make things work for development teams when really we should just be enabling them? So where we're doing things wrong is we're trying to do too much. We're trying to scale things that we can't possibly scale.
So, Grant, you bring up a very interesting point of view. Obviously, this is why we're having this conversation, where you made a claim you don't insert sec between dev and ops. I agree with you. Really, you want security embedded in development right at the beginning, right? So that by the time it gets to ops, it's in there. It's like Prego, right? It's in there. Is that kind of where your thought process is?
That's exactly right. We should be. I mean, security happens with design. It should be part of how project leaders and product owners think about what their products should be. They know that they want it to be fast. They know that they want it to be able to scale. They should also want it to be secure. So right back in writing user stories, that's where security by developers. It's important that developers understand what security issues there are and how to get around them, have the right kind of coding practices, the right templates, the right frameworks, and use the frameworks in the right way. And then by the time we get to ops, security should be easy. So the part that we've been most concerned with from a security point of view, that should be much easier when applications are running and built the way that they should. From a security point of view.
We shouldn't wait until the application's developed, QA tested, in production, and then do all of our security at the end?
I know, it's crazy, right? Oh, come on, you throw a WAF on the end, right? That solves all the security issues you could possibly have.
Right.
Yeah, you'll get a laugh for the WAF, that's for sure. You also mentioned that security teams trying to do all the security work or trying to do all the work. And it makes a lot more sense to spread security throughout the dev and ops processes. So what are some ways that the dev teams can take on some of that security, not just the responsibility, but actually do some of the work and understand both what does it mean to have security within a user story, but then when you're starting to write code, what does it mean to find code that has security flaws before they do reach ops and everybody, and we have to put that WAF on top of it.
Well, so I guess let's start with the fact that I'm very heavily involved with OWASP. I'm a huge fan of a bunch of the OWASP projects. Building security in, or the idea of security in, right at the beginning. I like to do that with Cornucopia, with the card game, help teams understand what types of security issues they can face, and get them thinking about, while planning for a sprint, thinking about what types of things they need to bear in mind. Input validation, encoding, you name it. We're doing cryptography, we're doing something with authentication, we're going to have a piece that deals specifically with authorization at the beginning. What are we looking at? And then they'll pay specific attention to those features. The next step is, once they're actually writing code, having tooling that provides them with feedback, much like tooling would provide them with feedback on performance issues or on some tactical issues that they might have in their code. So there are lots of tools out there. Synopsys provides some really good tooling around how you can actually better defend in the building part of the pipeline. So when developers are actually working on code, if I execute some tests, I should be able to see, yes, my test passed, functionally it works. It's a little slow in these areas. And if you do some orchestration for performance testing, you'll see that. And if you did the same sort of orchestration for security testing, you could see that too. So not just having the tools run at the end and then having us have a look at it and go, oh, you've got 10 million. Let's go through them one by one. Oh, you wanted to release tomorrow? No, that's not happening. We've got 100,000 issues.
Yeah,
Let's
the
drill.
age-old meeting where security and the application teams are sitting there going, "No, you got to address all these vulnerabilities before it goes in production." They're like, "No, it's got to go into production." The big fight that goes back and forth. And you said something else interesting, about the security team can't do all of this, right? Does that mean the security teams need to be? I mean, do they go away and really just become part of the development, the DevOps process going forward? There isn't a separate team. It definitely has to be embedded there. And are you seeing any of that working right now out there in the industry? Because I think we still see big security teams taking on a lot of these responsibilities.
Yeah, so big security teams are still a thing, and I don't think that's going to change too much. But those big security teams are focused either on running or managing the tools, or they're focused on ops side of things. So they're actually a subset of the operations team. Ops didn't disappear when DevOps came in, right? Their role changed. They ended up running infrastructure that everything ran on, rather than running the things that run in production. And the same is true for security. You're still going to have infrastructure for security. You're still going to have things that are required from a policy point of view, or in order for us to meet certain requirements from an industry perspective. So security teams will still be there, but you'll see a very big split between the security teams: those that are doing AppSec, that are in dev, those that are doing operations, that are actually still running those WAFs, right? The WAF's not going to go away. In fact, we may end up with Wasp in front of it instead of a WAF, but it's the same type of thing needs to be managed by the same type of organizational group. But the security team needs to start putting some of the responsibility for ensuring that there's no, I mean, SQL injection shouldn't be a thing that we should see ever again, but it's still in the OWASP top 10. It's still a major concern because it's the coding practice hasn't been changed. We're not thinking about it in the right way. And there are frameworks out there that should provide us fundamental different ways to deal with it. But the security team needs to help application teams take on those changes and apply them properly, and take responsibility for the code coming out secure, rather than this magical black box that I, as a developer, write my code, I throw it into this black box, and I get some results back that I don't really understand. Then I spend some time with the security team and they help me interpret the results. And all of this is very mystical and almost cryptic in many ways, because I see it as not being my responsibility and not being something that I have any control over. And both of those two things need to change.
I'd be curious to loop back in a second about the frameworks, but you've been mentioning a lot of tools so far, and let's drill down into the actual tools themselves, because one of the aspects is already you can use a tool the wrong way, and that was what Matt, for example, was mentioning, that litany of snooze fest to read through the results, and with the engineering team, and just everyone falls asleep. Have you fixed this one? Have you fixed this one, etc. But there's DAST, SAST, IAST. You mentioned WAF and RASP already. Are there one or more of these tools that you've seen either misused that too often that you think should be fixed, or on the other hand, are there any of these tools that you really like to emphasize because they actually are harder to misuse, or just give that much more quality of feedback for the dev team using them?
Yeah, so I'm a huge fan of IAST, primarily because IAST is all about the application team taking responsibility for things that are happening. There's no security team needed to be involved in IAST. You orchestrate the same way as you would for performance testing, same as you'd use a performance harness, and away you go. You run your normal functional tests and it gives you results back. Security teams need to get involved in helping to interpret those results sometimes, but primarily it's an engineering activity, right? The engineers can run it, the engineers can see the results, and they can fix them. And they don't have to do anything magical or special. They're just running their normal functional tests. You talked about SAST. SAST is probably the go-to for every security team because it always produces results. It looks at source code. It doesn't need anything special. It doesn't need to be running. It doesn't need any level of testing to happen. It just exists. And if I look at the code and it looks like there might be an issue, I'll flag it, and then I'll have somebody review it. And that somebody is usually somebody in the security team who doesn't have a lot of time. And they'll then push it onto the developer and say, fix this. And that's how we end up with 100 million, usually actual issues, but often not, often false positives, mainly because SaaS tools aren't actually looking at the code as it runs. There may be whole sections of code that have issues in them, but the sections of code can never be executed, right? They're completely orphaned. Or input validation's happening somewhere else, and because SaaS doesn't actually see running code, it doesn't actually see the data flow through that piece of code. So it doesn't see it. It's already been validated somewhere. So SaaS, yeah.
I was going to say, yeah, sorry to interrupt. I suspect you're going to go on to DAS from there. But before we go on too far, I'm curious too, because you were saying SAST, you were pointing out quite well, I think, that it often misses context of, is this bug actually exploitable, or is this really a flaw I need to care about, or is this something that's theoretical, or it's a code path that can't be reached by an attacker? I'm curious too, we moved on from IAST a bit quickly, and what have you seen about in IAST deployments? Because that's one of those areas that with source code, everybody can at least grep and just treat source as text and look for common patterns. But IAST often has some difficulty getting set up. Setting aside even, do you have a lot of tests created for, just non-security tests that you can instrument for your team?
Yeah, so IAST is absolutely perfect, except for two minor, not minor at all, they're major flaws, two major flaws. The first is you need functional tests. If you don't have code paths tested, they will never be executed, and IAST will never see the path, never see the execution, and will simply not know anything about what's happening there, except that sometimes they will know that there is actually a code path that was never executed. The second flaw is that it's very much framework and language dependent, right? So if you're not using one of the frameworks that's supported by your IAST tool, there's nothing they can do to help you. So those two minor, not so minor, pretty massive issues aside, if there are quite a few teams that I've worked with that are implementing IAST in a very real way. There are a couple of products out there that are doing fairly well. I've actually recently done some run the Wasp benchmark against a couple of new contenders in the IAST space, because it all used to be, I don't know if I'm allowed to mention any brand names on here, but pretty much everything that I've seen has been Contrast, because they've been in this game for so long. But for example, Seeker was mentioned earlier. They're doing incredibly well, and I think Seeker actually used the OWASP benchmark as a way to ensure that their product is coming off the line and still doing what it should be doing. But as long as you have 100% code coverage in your testing, and you have used the frameworks in the way that the frameworks were intended to be used, or that the way the IAST guys think the framework should be used, then you're clean. It's going to be a wonderful world, and security becomes an absolute dream. In practice, you're lucky if you've got 70% code coverage. In practice, you're lucky if half of, well, actually, more accurately, the largest organization that I've recently done a thing with, probably 15% of the total code base actually could even use SAST. Could even use IAST. So yeah, although that organization also has issues where they're having to use some old IBM products for SAST, because they're still having to do static analysis of COBOL. So there's a large chunk of work there with really old frameworks, really old languages that still need to be supported for a while.
And so if you can't use IAST because of the challenges you just mentioned, we rely on SAST and DAST, black box testing, as our alternatives. But we know how inefficient both of those are from a false positive perspective, right?
Yeah, so DAST is almost zero false positives, except that it's a whole lot of work to make any DAST products work properly. And that work falls almost entirely on the security team, who not only need to understand the DAST product itself, but they also need to understand how the application is running. And that context is often missing for the security guys. So DAST's biggest problem is that we're not getting enough value out of it, because we're not seeing half of the things we should. All the things that DAST highlights generally are issues that need to be resolved, but that's maybe 5% of the total number of issues actually in the product, or 15% if you're lucky. And if you're looking at DAST products, Zap is performs the best are the ones I've managed to test so far, and it's free. So if you could spend the time in security engineering time to actually get it up and running and working, probably a great way to go. But they're flawed, right? And SAST, well, SAST is flawed because it looks at everything. And then I have arguments with security teams around whether those code paths that can't be reached, whether vulnerabilities in them actually need to be resolved. And the reality is, it depends on the policy. And if the policy says they must, well, somebody's going to enforce that. Personally, I think that if code paths can't be executed, then there's no issue. There's no reason to be spending any time on that code. Otherwise, you should actually just be removing the code, right? You should be refactoring. Never mind fixing the security bugs in it.
That last point's a great point too, about just the idea of deleting code is one of the best security decisions you can ever make, because it, as you're just describing, it's a code path that might not be exploitable, but it also means if you don't have it, it's not going to be exploitable in the future. And it's also tamping down tech debt, making just more maintainable code in general. So I just want to really emphasize and echo that the importance of that comment. And I like what you were describing too, is because it sounds like with IS, to kind of repeat some of this back, is that you're actually just dropping security on where the testing has already been being done for the normal development process. I mean, a good DevOps team, or just a good Agile team, or whatever description you want to use, is already going to do some type of functional testing and other type of testing for their code. IS just helps to introduce the security dimension of that. And you don't have to wait for IS to run like you necessarily would for SAST or DAST. And so you're not adding you're adding a step, I guess, in parallel rather than serializing the process is another way to look at it.
Yeah, and in one of the large organizations that I recently implemented a whole bunch of the stuff with, if you could get your code to run through the IS path and you had a high enough code coverage, as in your test bases were high enough to cover most of the code paths, you could bypass having to deal with the SAST pipeline at all. As a reward for, you're using the right tools, you're using the frameworks in the way that we most expect them to be used, and you have good code coverage, so away you go. Run with it.
You've been mentioning,
you're right. It's a slight overhead on executing functional tests, because there is some manipulation happening. There's a bottleneck in every code path, but it is not a whole batch of separate tests that have to run at the end after you've proven that it functionally works. That is this big add-on, right? As you were saying, it's the time from writing code or coming up with a feature to executing it in production is much shortened if you can go with something that is built in as part of your normal testing process.
And a lot of what you were saying is we're starting to touch on the idea of metrics, and I think hopefully informative ones, because when you were talking about code coverage, so that's pretty informative. Already performance, treating security or approaching security like DevOps teams are measuring performance, because load times, other type latency, all of these are actually pretty measurable and informative for making decisions on how can we make the app better. And just at your last point there too was talking about sort of that time to deployment or time to finish testing or time to wait on testing. Again, probably another good metric to start considering there. So I guess I mentioned code coverage and time to wait on a tool. Those are performance isn't quite security. But what are some additional metrics that you've seen been successful, or that you've really been pushing teams to try to adopt in terms of saying, are we doing security right? Are we doing AppSec right? And can we show that we are?
Yes, so that's a little difficult because, as you said, I mean, performance is nice and easy. We can get pretty good metrics on what is performant enough. The metrics around what is secure enough, that's harder to determine. I think
don't we just want 100% secure?
Yeah, 100% secure is turned off, right? Unplugged, turned off, buried in concrete at the bottom of the ocean. That's
right.
Pretty close to 100% secure, as long as you first completely wipe the drives and overwritten them several times and possibly
exactly and have something completely unusable.
Yeah.
And how much do you charge for that option?
It does come with a slight downside in that your customers can't actually use the service. If you're okay with that, then that's fine. We can add it on for free. That's really not a problem. Although the cost is going to be pretty high. Nothing more expensive than something that's free.
I didn't mean to disrail you there mid stream at the top, but one thing is, take it back a little bit about some of the stuff you're saying there. You're a pretty heavy proponent of using testing tools from a security point of view. Have you seen, it sounds like you're working with some fairly large, fairly mature on a security scale customers. Have you seen any of them go to the degree of, I'm sure you're familiar with test-driven development. How about security test-driven development? Have you seen anything like that out there, or is anyone being that cutting edge, if I dare use that phrase?
So I've only seen very few teams that are even doing TDD. The teams that are doing TDD, test-driven development, are the same types of teams that are trying to apply newer frameworks and doing something sexy with how they're producing stuff. So a lot of Node.js, and as a result, their testing strategy is almost entirely reliant on them helping to build tests for dynamic tooling, because the security teams aren't able to keep up. The teams that are probably in the best position to do security test-driven development are the teams that are actually using frameworks that IAST would support. And I haven't seen any that have specific security testing, but the teams that are getting close to that tend to be, they're using basic Java, and they're using Spring Framework, and they're doing things in a very well understood, well experienced environment. And then they have a good level of functional testing, which, because they're using IAST, provides you with security testing. But nobody's actually writing security tests as part of their, well, none of the teams that I've worked with writing security tests separately, unless, as I said, those Node guys.
Yeah. I just I dreamt that up while we're talking here. So I'm. Does that sound like is that idea within the realm of sanity? I mean, I guess the full thought process in my head is, if you're playing like protection poker or some sort of form of threat modeling, while you're going through that process, actually say, hey, now we've come up with these things. This would be a way to test them as we develop. Is that am I really putting too much load onto a developer when think about something like that, or would that be valid in maybe some use cases?
So if we go back to how I keep pulling security back to performance, right? So would we do that from a performance perspective? Definitely. In fact, there are teams that write loads of performance harness testing before they even write actual code. And they do that because the code that they're going to write needs to be incredibly performant. So if you have a very high need for security in a particular product, then I don't see why you wouldn't go that approach and ensure that as part of your development, you understand what the security criteria need to be. But I think even banking software isn't being built that way. And I can't higher levels of security than banking. Although right now, maybe stuff the NHS is using.
Talking about
so John, you came up with a whole new market.
Yep.
Just
like millions.
That. We may need to work on the acronym, but it's definitely a good market.
Yeah, STDD is probably not a very good acronym for that one.
Yeah, exactly. Grant, how have you seen a lot of this? You've been talking about doing it wrong, and I think at one point I did hear kind of a glimmer of hope for how things can go right. Meaning, you were describing a team using IAST, and if your deployment passes through IAST, you can skip all of the source checking or a bunch of the other what might be more onerous or maybe even unnecessary types of security checking, or even let's call it security delay, or a security budget that you have to spend. Have you seen this change conversations with teams so that they can, rather than security saying, well, you have this tool says you have 3 highs and 4 mediums, you can't deploy until you fix all the highs. Does it change those types of conversations? And if it does, is it changing them for the better or just making it harder?
Well, I think it's changing them for the better. I have seen some of those conversations happen. what you end up seeing is that there is some profile based on your application, the type of data you work with. These are the requirements that we then set for you. And the security team like getting involved in that and setting up what those boundaries are. But the boundaries become more guide rails than actual bumpers. And those guide rails help teams to understand this is what I need to achieve in order to move forward to production. The pathway was called Trust but Verify, which means if you meet the requirements that we defined with your team at the beginning, and you go through the processes, you ensure that your team has had the right level of training, people who were involved in training and scored well enough in whatever the training process was, as part of a release. When that release goes into production, it goes through IAST, and if the IAST tool says it's okay, and the okay is still a number of highs, number of mediums, and number of lows, then it's DevOps into production, as in a security team doesn't block it at some point, and this organization, a change management team, doesn't block it somewhere further down the line, because it's dotted all the I's, crossed all the T's on the way through.
Mm-hmm.
It does make it easier for those teams to get through. And then the verify path is that there's still pen testing happening. There's still a parallel path where static analysis will be done on repositories on a regular basis. And if there are any issues that are found by static analysis that are determined later to actually be issues rather than false positives, then you have to come back and fix them. And then the team has to go through a process of proving their worth again, right? Because you let these slip through. But it does offer a way for teams to continue to be agile without security actually getting in the way. And security should be enabling that faster move to production and just ensuring that it is safer to do it that way rather than, well, I mean, we basically stand as a gate. We say, no, you can't go in. And I don't care that this is the most important thing the business is doing. It can't go in because it doesn't tick all the tick boxes, which is terrible. So we need to make sure that the tick boxes that we do have to put in place are reasonable. A lot of these organizations, they're regulated, so they have to meet certain regulatory requirements. So you can't get away from that. But as long as they're sane, and as long as because the team's writing the code, they care about the product, right? This is their baby. This is something that they want to be proud of. They do act as, good guardians of that, and they push it through the way that it should go. They do the best thing that they can do. But you need to provide them the tools, and you provide them with the knowledge so that they know how to do it.
Well, actually, speaking of tools and knowledge, you've been quite an active member of OWASP. What are there areas or projects within OWASP that you'd really like to highlight for our audience, or for that matter, really pull them in to participate and collaborate more and build up some of these tools or areas of knowledge?
Sorry, I missed the first part of that. What was the?
You're no worries. I was saying you're quite a participant in active within OWASP and a supporter. So I was just curious if there are particular projects that you wanted to highlight for our audience.
Well, there's two projects that I spent a lot of time reusing. Actually, I guess if I'm going to list 4 projects that everyone should have looked at these and touched on these in some way. The 4 projects are Cornucopia, because it's the easiest way to do very basic level threat modeling with teams right up front and make sure that they can run it themselves. You don't want security guys in the room once they've learned how to use the cards. The second one is OWASP. As I said, it's a phenomenal product. If you need to do dynamic testing, it's right up there. And if you're doing fuzz testing, it's a great tool. But then the other 2 projects that kind of really help teams are probably SAM, which looks at the maturity of a secure approach to development, and then finds ways to measure that security and measure how it improves over time. And then the ASVS, which is the Application Security Verification Standard. It's the only official standard that OWASP puts out there, as in, if you meet these requirements, you can certify at level 1, 2, or 3. They're both really good projects, and they are now working quite closely together to ensure that as you become more mature in your SDLC, the resulting applications are more likely to meet the ASVS. And between those two, you ensure that your teams are doing what they should be doing, and that they're producing the things that you should produce to have good code at the end from a security point of view.
Cool. Yeah, thanks for that list. And I love that there's quite a theme between SAM, ASVS, and Cornucopia those are really projects focused on developers and what to do, rather than something like the OWASP Top 10 that's more saying, don't do these things because you'll have SQL injection that we shouldn't have to be worrying about, as I agree, and all these other flaws. So I think those are really three items that are great to highlight. And so I appreciate that. And also appreciate you taking the time to come chat with us. Any final words or comments you'd like to leave our audience with?
I guess mainly we are doing application security wrong because we're trying to do it all ourselves. Try work with the development teams that you have to manage. Herding kittens is how I've heard it described. You don't want to be doing that. You want to teach the kittens to chase after those balls of wool on their own. So show them how much fun it can be and go ahead for it.
That's fantastic. And we definitely can't do the Application Security Weekly podcast by ourselves. And we need guests like you to come on and share knowledge, share that experience. So thanks again, Grant, for joining us.
Thank you for having me. I really appreciate it.
I also want to thank Matt and John as well, and thank all of you for listening. We're going to take a quick break, and then we're going to return with News of the Week.